Okay, here's one of my favorite questions from dynamics. So it's Newton's third law question. We have two blocks sitting right next to each other. You push on one block and you want to calculate what's the reaction force of the bigger block onto the block that was pushed. Okay, so the question says we have a 4 kilogram block, that's block A, sits to the left of an 8 kilogram block, that's block B. There's a 10 Newton applied force acting on block A, and we want to know what is the force of the larger box on the smaller box. So another way we can write this is, what is the force of B on A? So that's what we're looking for, and got to make sure it's a vector, because a force is a vector. So when you're dealing with these kinds of questions, always you break it up into our free body diagrams. And especially when you're working on problems where things are close together and you have a force acting on both of them, let's make a free body diagram that takes into account both blocks. So we'll call this our composite free body diagram. So we're going to imagine these two blocks are combined into one big block with a total mass of 12 kilograms. So we have our big, let's draw it as a block because why not? So we have a big block of 12 kilograms. So both of these combined, we know that we have our applied force of 10 newtons. We know we're going to have a gravitational force, and we know we have a normal force. Now, because we're only dealing with horizontal forces, the normal force and the gravitational force don't really come into play, but still good to write it out. So if we write out the net force acting horizontally, so the sum of the net forces in the x direction here, it's just equal to 10 newtons because that's the only thing acting on this. So if we have the total mass times the acceleration, and that's equal to 10 newtons. And remember that I should write here, the total mass is equal to 12 kilograms, right? Because that's just 4 plus 8. So we have 8 kilograms times the acceleration is equal to 10 newtons. Divide both of these by 10. So we'll get an acceleration equal to 0.83 meters per second squared. Okay, so that's important. So that's the acceleration. And because this is a system of two things, that means that block A is going to have that acceleration and block B is going to have that acceleration because the force acts on both of them. So now let's draw our free body diagram. We can pick whichever one we want. I like to usually pick what we're working with, a free body diagram that has less forces going on, just so it's easier. So let's draw a free body diagram for block B. So block B, so this is block B, 8 kilograms. So the only thing that it's experiencing, yes, we have a normal force. Yes, we have a gravitational force. But block B is experiencing that push, right? But it's experiencing that push as not 10 newtons, but the force of block A on block B, right? So big thing that people get wrong is only A is feeling that 10 newtons, but B is going to feel that it's going to be less than 10 newtons because it has to go through A, and then we're getting that A on B action. So let's go and figure out what that is, right? So again, we only are worrying about horizontal forces. So we write the sum of the net forces in the x direction. Well, here it's just equal to F A on B. And the sum of the net forces here is going to be the mass of block B times the acceleration. And that's going to be equal to A on B. And that's going to be 8 kilograms times 0.83 meters per second squared. And that will give us, let me get my calculator out here, 8 times 0.83, 6.64. Now, if you're studious, you'll realize that this should be 0.833 repeating. So this should technically be 6.67 repeating, but we'll just call it 6.64 newtons. So that is our, let's do our FA on B, and let's write this as a vector, is equal to 6.64 newtons, and the direction is we're going to the right. But we wanted the force of FB on A. So what do? Well, here's where Newton's third law comes in hand, because whenever you have an action and a reaction force, two things pushing against one another, we know that every action has an equal and opposite reaction. So we have FA on B is 6.64 newtons going to the right. Well, then that means that FB on A is going to be 6.64 newtons going the other way. I really hope my fingers aren't flipped in the video. It might be, that's too bad. But we'll get that FB on A, and because we're flipping the vector, that 6.64 stays the same, but the direction is going to be opposite. And that gives us this here, and this is because of Newton's third law. And so these questions are really fun. This is kind of the most basic version of it with no friction. If you have friction, then you basically, when you're doing the free body diagrams, you just have another term to worry about. Then you have to bring the normal force and the force of gravity. But this is, if you can master this idea of, okay, make a composite free body diagram, get the acceleration, and then break it up into two other free body diagrams. And once you get one force, you get the equal and opposite of the other, then you're good to go. So yeah, great question. Big fan.